Hello students, a very warm welcome to JEE English, and today we will be having a mega quiz on electric potential, guys. So students who are aware of the process, you can quickly get onto that quiz. But let me shortly brief you through the process. Do remember, don't limit your challenges, but challenge your limits. We'll be discussing solutions throughout this session as we are moving into it. So yes, do remember, do not limit your challenges, but challenge your limits, guys. So the code would be 939169. Students who already know the process, you can join it. So the process has been changed a little bit. I will quickly appraise you on the process. It should be first of all, download Unacademy learning app. If you don't have one, just type in Unacademy on your Google Play Store and App Store, and then click onto this link, click onto this button, and post that, guys, choose plus, and post that choose test on the bottom, and then choose this live quiz column, and post that. You'll be able to see a join quiz, and you click onto this and you'll enter the quiz ID, which is going to be 939169. So yes, students, you can quickly join the quiz. You have 20 questions in this session, and yes, there will be of course we'll discuss, we'll have hints, and probably if possible we'll also discuss the solution. Yep, and you can let me know if there's a lag in the video, etc. So you can correct it out. You can quickly join the quiz, guys. It's 939. So yeah, a bit change in the interface, so just click on to this live quiz button and then choose join quiz, and then enter the quiz ID 939169, guys. But we already have one participant, and yeah, we'll be anyway commencing the quiz in next 5 minutes. We can have more participants, you can join, but do share this video, do like this video, because it's going to be a very interesting quiz. We'll be discussing solutions all along this quiz, guys. So yeah, 939169. And students, the interface has changed a little bit. You can rewind the video a bit. We have 2 participants, and that's really good. And we have so we'll be discussing the solutions as well, guys, so don't worry. You can join the quiz now, and later on keep track of the solution. But the most important thing is you will be attending it all along with me, so you must be solving it on a paper, unlike not doing it mentally, because mentally you can't do some of the questions. That is not possible in this case. So make sure you are attending this quiz, right? All right. Already have 2 participants, guys, and we'll be anyway starting the quiz in next few minutes. So you want to make sure you are attending this quiz, guys. It's whatever we have covered until now. I've tried to potentially remove the questions that was not covered in the syllabus, but yes, amazing. We have 3 participants now. 2 more can join, and we'll begin the quiz. Else we'll wait for 5 minutes and we'll begin the quiz anyway. And students, for your information, a little change in the process. You must have Unacademy learning app downloaded from your Google Play Store and App Store by just typing in Unacademy. And do let me know if you're seeing any video lag, and then click onto this link and install it. and post that choose plus. You need to log in and then click on the left hand top corner extension bar, choose plus, and then you will have to choose the tests, and then you will have to choose the live quiz, and then you will have to click on the join quiz. Okay, little bit change in the process, that's it. Quickly join the quiz, and post that you'll be entering the quiz ID. Once you click on that join quiz, there will be a pop-up and you can enter the quiz, this thing. And very warm welcome to this quiz session, guys. You will enjoy it because we are going to discuss the solutions as well, possibly, if at all some concept that has not been covered, we will take up a separate class on it. We have a we'll have a lecture, like an entire lecture post this quiz on this topic itself. So make sure you are attending this quiz, students. Alright, so already we will wait for another 4 minutes and we'll begin the quiz. So copy this code and share it with your friends, share it on your social media. Let's have more of the students on board. It's anyway a free of cost feature, and it's going to be very interesting, guys. Trust me, like it's like 20 questions, 80 seconds. If you feel less, do a thing, try to work out the solutions along the way. Your approach should be correct. Anyway, I'm going to give you the hint for all of the questions, so it should not be a problem, I guess. So make sure you are attending it. Okay. All right. All right. 3 more minutes, guys. 3 more minutes. We will be beginning the quiz. So pause this. You have a break, of course. Like 80 seconds is going to be each question, and then there will be like a leaderboard. So yes, of course, we have our students over here, and it's going to be very interesting, guys. Make sure you're attending it. So yes, you can start attending the quiz. Get your pen and paper and try to solve it even if you don't have the app. First of all, download the app, click on that left hand top corner extension bar, choose the plus. Do not forget to log in, sign up for the your account, and then click on the test tab on the bottom. Then there will be a live quiz button. You can click onto that, and then you'll see like you can join quiz. You can click on the join quiz button, and you will be able to type in the code. Right, I think 2 more minutes, not even 2 more minutes, 1.5 more minutes, we'll be beginning the quiz. Hi Mahendra, hi. Of course, we'll do solutions after the quiz, Aaron. Guys, I don't know, for some reason your chat is not popping up on time. Hi Mahendra. Good. Yes, we will be having you. So Aaron, why don't you join the quiz? We will be also discussing solutions for everything. We'll be discussing solutions along the quiz as well. We'll be discussing the solutions after the quiz as well. And do let me know, Aaron, which is that part of the question that is not clear. You can comment on the live chat, and I will be having a look at it as well, and probably after that question I'll be giving you a short hint, and if it's still not clear, we'll do a thing, we will go through the solutions. Of course, I've chosen some of those questions that are not present, those concepts that wasn't discussed in the class. Hence, amazing Mahendra. Yes, I can see you. Yeah. So half a more minute, guys. It's already 7:44. So we will be beginning the quiz no matter what in another half a minute. So yes. Oh yes. 1, 2, 3. Quiz begins. Amazing. We have very brilliant students on this quiz. Let's get started, guys. All right. This is a very interesting question. A fully charged capacitor has capacitance C. It is discharged through small coil resistance wire embedded in a thermally insulated block of specific heat capacity S and M. If the temperature of the block is raised by delta T, what is the potential difference across the plate? There should be a little bit of change around this. Let's come to that part later on. So, okay, there is a 2. Okay, do remember there should be a 2 on the top. And it should be in a root. Why? How do you do this question? Ms delta T is the energy that has been dissipated, which is equivalent to that of half of CV square, not the entire CV square. Okay, so 2 MC delta T divided by, it should be capacitance, of course, you know it. The question is over, guys. That's it. I didn't think this question should have been that easy. Alright, that's how you do it, guys. I hope you understood the concept. So it should have been under root of MC delta T. Amazing, amazing, amazing. Amazing, guys. Amazing, amazing. I think it's slowing down a bit. Let me do a thing. Let me just quit some part of it. Anyway, students attending the quiz, you will be able to watch it. Just quickly. All right. So an infinitely long thread of charge density lambda lies along z-axis. The potential difference between A and B is going to be how much? Notice this question. This is a very simple question. We'll discuss in detail about this question. What should be the answer? Right? Now I think it should be fast. So there's a lag, I guess, and what reason this lag is happening. Alright, guys, how do you work around this question? So you need to basically see what kind of surface it is. It is going to be a equipotential surface. It's going to be 0. Right, good. I think there is a little bit of lag. Let me do a thing. Let me do a thing. Let me quickly quit this presentation as well. A bit of lag and streaming. Alright, guys, what should be the work done? 20 coulomb charge moved by 2 centimeter. The potential difference should be Q delta V. We did this thing already, and you know what should be done. Okay, you can see the answer on the screen or what? I didn't know that. Alright, guys, you know the answer. It should have been the answer. It was marked 0.1 volts. 2 joules divided by Q gives you the potential difference between those points. Alright, now we have a very interesting question. And a hollow metal sphere of radius 5 centimeters charged such that Potential on its surface is going to be 10 volts. The potential at the center of sphere is going to be how much? We've done so many questions like this. What it should be? It's a hollow metal sphere. Do you think potential is going to be 0? Or same at a point 5 centimeters away from the surface, same as a point at 25 centimeters away from the surface? This could have been a quick question, quick answer, right? It should be the same as on the surface, right? We did so many questions around this. All right. So yes, it should be. I believe there would be a little bit of, the video will be streamed a little bit behind. So you'll be getting possibly the solution only at the end, not in the beginning. So yeah. But you should be working on your own as well, guys. Right? Alright. Good, Mahendra. Good, Gopalakrishnan. Good, Ambika. Good. Yeah. Guys, you can still join the quiz. The code is available if you stream back in the video. So what should be the answer in this case? In a certain region, the potential is given by V is equal to K into 2x square minus y square plus z square. You would be partially differentiating it. Don't worry, we'll take it up as a separate case in our lecture today. This is one of the things that we haven't done before. Hence, I'll directly tell you what you need to do. You need to partially differentiate, but do not forget the signs. So if this is V, what I should be doing? I should be doing dV by dx, or sorry, in this case, it's going to be partially differentiated V by x minus of dV by dx, I cap plus, all to the minus, or minus dV by dx minus dy by dx, j cap minus dV by dz, k cap. So if you do that, what would you get? 4x I cap, 4x I cap substituted, it's going to be 4, and there it's going to be 2 and 2. Under root of 4 square plus 2 square plus 2 square, isn't it? How much that should be? That should be like 16 plus of 8. Just a moment. 4, no. 4 square and 4 square plus 1 and 1, isn't it? No, 4 square plus 2 and 2. Just a moment. 16 plus of 4 root of 24. Right. I think it will be like k under root 6, something of that sort. So just a moment, let me rethink about the last question. So it should have been dv by dx, so that would be like 4x minus 2y plus 2z, right? So 4x, it should be 4 at 1, so under root of 4 square, that is going to 16, 2 square, that is going to be like 4 root 24 under root 24 k square. Root 24 can be written as 6 into 4, so it would be like 2k under root 6. Alright, now in this question it's a similar one, but potential has been varying all around. So in this case, what you need to do, you will be doing same thing, del v by del x I cap, del v plus del j del z k cap. So if you solve this entire thing, it's going to be a complicated root where you would have something like under root of 43 whole square plus under root of 49 whole square plus of under root of something like, I think the last one would end up being something like 50 whole square, etc. It might be 83 or 88.9. I think the answer is D. Alright, let's move on to the next question. Then we'll go through the solution as well. Don't worry, I have these questions on my presentation today, so we'll be doing it. Alright, guys, this is a very interesting question. You need to understand this in detail. To quickly give you a solution, what you need to do is, first of all, find the electric field, then apply Gauss law, try to identify the flux, and from that flux try to substitute the charge is equal to charge density multiplied by volume, and you will also notice something unique on the electric field, and when multiplied with area it will also yield a volume, but ultimately you will have something like a 2 and a 3 left over. Okay, 2 and 3 left over. That will not yield volume but r cube on the other side. So you would find the answer to be something like minus 6 so and so not epsilon naught. Okay, so let me explain you the question. Okay, so what happens in this case is like you would have a potential, you need to differentiate it. If you differentiate it, you will get an electric field. Electric field multiplied by area would give you electric flux. Electric flux is nothing but q by epsilon naught. Q is nothing but rho into volume by epsilon naught. And what you need to do is there in the place of electric field into area, you will find something like radius vector is being multiplied twice. Okay, that way you will get the answer. Aditya, the code is going to be I don't exactly remember. Let me just quickly have a look at it. It's going to be 939169, guys. Aditya, can you type it out as well? 939169. A positively charged particle is released from rest in a uniform electric field. The electric potential energy of the charge remains constant between the electric field, or increases because the charge moves along electric field. Did you get the code, Aditya? It's going to be 939169. Okay, you can type in that code. So now the question comes, what happens if a positively charged particle is released in rest in a uniform electric field? It will move along the electric field. If it's going to move along the electric field is doing the work. So what do you think will happen to the potential energy of the charge? Should it be increasing or decreasing? Right, think about it, like in this way. You have a charge and that charge is repelling it, and ultimately you are moving up until certain distance. In that case, what would be happening? Your decreases because it should have been C. I wasn't able to mark it. I think very good, amazing, guys. All right, we have another interesting question here. What should be the total energy of the system? How do you work on this question? What would be the total energy of the system? There's only Q1 and Q2 charge. So it should be you think it is going to be Q1 square by 8 pi epsilon naught divided by R1. Actually, we haven't started discussing electrostatic potential energy. We'll soon have that class as well. So in this case, now it cannot be, one charge all alone cannot have its own energy. To have a potential energy, it needs system of charges. So answer A is not true. Answer C is not true because you're not going to do any, like wonder math, etc. Now it's going to be just B as well. Okay. All right, guys. Good. Gopalakrishnan, good. Mahendran, good. Ambika, very good, guys. Very good, very good. Aditya, you can still join the quiz. We have still 10 more questions to go on. A small oil drop of mass 5 into 10 to the power minus 6 kg is hanging in rest between two plates separated by 0.1 mm and having a potential difference of 500 volt. The charge on the drop is dash and okay, what you need to do? So the plates are like this. What is the electric field going to be? dV by dx. In this case, it is going to be 500 by 0.1 mm. Notice it carefully, it's mm, guys. Okay, and it's in volt. So ultimately, you need to convert it, and that would be like 0.1 divided by 500 divided by 0.1 into 10 to the power minus 3. So it's going to 10 to the power minus 4. So it's going to be 5 into 10 to the power 5 is equal to mg. Mass is 5 into 10 to the power minus 6. Okay. So mg and electric field should be how much? It should be what is charge should be how much? Charge should be like something, I guess. Basically, you have to do Q into E is equal to mg. You are given the mass, you are given the electric field. Electric field is indirectly given to you. That is going to be like distance between the plates. I mean, like voltage between the plates divided by the distance. Okay. All right, let's move on to the next question. I think a non-conducting ring of radius r is charged as shown. This is a very interesting question, guys. So what would be the electric field at the center of the ring? Do you think it's going to be 0? No, right? If it was uniformly charged, it's going to be 0. Now it's going to be all in a direction, right? It's going to have a direction. The electric potential is going to be 0. What do you think? Is this true that the electric potential is going to be 0? I think, you know what, you don't have to work very hard. Like, I don't think 2 correct answers are given. So, probably, answer, I'm going to mark the answer B. You know why? Because I'm not even going to work around C and D. This is just for, I'm not trying to solve it. I'm just going to give you a hint how to work around in an exam. So, electric field is not going to be 0. We know that electric potential is, of course, going to be 0. It's, like minus charge. Something is placed over there, this ring would be having some effect of potential on it, but that is going to be negative and this is going to be positive, hence it's going to be 0, guys, right? I'm not even solving the rest of the 2. You can do that as well. What is the electric potential at the center of square? We had a very similar problem, but I think you should notice the question carefully, guys. I think 2 plus q are present, 2 minus q are present. And what would be the electric potential at the center? Haven't we done a very similar problem? Don't worry if you haven't done a very similar problem, we'll take it up in this class. But what should be the answer in this case? 2 plus q, diagonally opposite. 2 minus q, diagonally opposite. Electric potential at the center is being asked. Minus q plus q. Minus q plus q. I told you something. Make use of k q net divided by r if all are like equidistant charges. What is q net in this case? 0. Isn't it? Your electric potential should be 0. Alright, I don't think much of explanation is needed in this case. If it was minus q, etc., then the answer would be different. But I think it's plus q, plus q, plus q, minus q, minus q, plus q. Alright, amazing, guys, amazing. Really good. XP points is also increasing for you. That means you're solving it really fast. Pretty amazing, guys. Alright, 4 identical charges are placed at the 4 vertices of a square lying in YZ plane. A 5th charge is moved along x-axis which passes through the center of the square. Okay. Now what is happening? A 5th charge is moved along x-axis. So think about it, lies in YZ plane. That means the center is going to, like an axis is going to pass through its center. That is going to be like 4 vertical charges lies 4 vertices of a square lying on the YZ axis. If you imagine this to be Y and Z, X is going to pass through the center, And what you're going to do, FF charge is moved along x-axis, which passes through the center of the square. The variation of the potential energy along the axis is going to be how much? So what is your potential energy equation going to be? Basically, it has to be some think about it. What would you get in the denominator where the potential energy is going to be maximum? So that way you will be able to deduce the answer. So potential energy, it's all positive, assuming it's all positive. There can be two possibilities, but it's not a discontinuous function. It might be a continuous function. So I think B should be the answer. Okay, you should mark B, right? Okay, it's not a discontinuous function, right? It's a continuous function. Okay, two identical particles of mass m carrying a charge q each. Initially, one is placed at rest on a smooth horizontal surface and the other is projected along a plane directed towards the first particle from a large distance with a speed v. Okay, it's no friction, anything. So two identical particles, one is mq. So how do you work around this question? Again, it's a potential energy question. We'll take it up, but let me quickly give you the hint around this. So equate kinetic energy. Kinetic energy would be converted, like would totally get exhausted at certain point, and when it would get exhausted, when this entire kinetic energy gets converted into potential energy, and that is going to be a point at q square by k into q square by r, both are q, I guess, is equal to half mv square, right? And that way you should be having C as your answer. And sorry, because we didn't discuss this concept yet, we'll get started on it soon, don't worry. Okay, I hope you understood this point. Okay, kq square by r is equal to half mv square. Amazing, guys. Really. Alright then. Equation of an equipotential line in an electric field is y is equal to 2x. Then the electric field strength vector at 1, 2 is going to be. So electric field y is equal to 2x is given to you, and the equation of an equipotential line. So electric field should be perpendicular. Yeah, Nauman, you can start attending it, but you should have attended the earlier classes as well, because electrostatics is the beginning of second year, right? So guys, the concept is like equipotential surface is going to have an electric field perpendicular to it. What is the slope in this case? m1 into m2 must be -1. And now think about it carefully. What should be a slope? Here y is equal to mx2. There you should have a slope which is going to be -2, and which is the case, sorry, -1/2. That should be T, right? Nani, the code is guys, the code is just a moment. It's going to be 939169, Nani. 939169. Okay. Did you get me? 939169. I hope you are able to hear me. Nine 39169, guys. Okay. Alright. How do we solve this question, guys? This is n drops are being of each charge to potential V coalesce to form a single large drop. The potential of the large drop is going to be how much? We'll take up a similar question in our practice session today. But n drops, n into V is equal to V dash. So your V dash, from there you would get the radius. And of course, charges would add up. Okay, charges would add up. If it's Q on each drop, it's going to be N into Q. So K into N into Q divided by that new R dash. What is R dash? R dash is nothing but under root N divided by 1/3 into r. Okay, so that's small r. And when you take that and keep it on the denominator, on the numerator you have n, so it should be v into n 2 by 3, right? All right, guys, but I think marking this is lagging the video, so I'm not going to do it from the next time. Okay, I hope you got the code, Nani. It's 969169, but stay tuned, we'll be getting into the entire lecture series. Guys, I don't think I'm going to mark the answer. It's a very similar question, and the potential at a point x measured in micrometer due to some charges situated on the x-axis is given by 20 divided by x square minus 4 volt. The electric field at x is equal to mu m is going to be how much? If you have any issues, take the denominator as x minus x square minus 2 as some k square or some y square and solve it. Okay, and both should yield the same kind of answers, and you would find that thing like 3 you can't do that actually. You'll have to individually solve. You need to differentiate this equation with respect to x and substitute x is equal to 4 micrometer. I can't solve it right now without a pen and a paper, but you can do it, I believe. So try to do it, but still I'll try to do a thing that would be trying to guess the answer. I'm not that quick right now. We can convert this into x minus 2 and x plus 2. Differentiate. Alright, guys. Good, Nagendra. Amazing. So yes, students, get started. Don't be afraid of the quiz. Don't limit your challenges, but rather challenge your limits. So charge Q is distributed over two concentric shells of radius r and r, such that the surface densities are equal and placed on the same axial points. The potential at the common center is going to be how much? Concentric circles, concentric shells. Now they're asking you for what? Guys, haven't we done a very similar question? We have already covered this concept. The potential is being asked. So it's Q divided by R by R is nonsense. 0 is a nonsense. It's a potential. So B and C both are nonsense. You can eliminate them. Between A and B, you need to A and D. You need to make the decision. So what do you think is going to be KQ by R divided by KQ by R plus of KQ by R? Is that what you're expecting it to be? Now think about it carefully and try to solve the answer. Try to solve the question. They have given you Q is distributed over two concentrics, not one concentric shell but two concentric shells. So Q is distributed over two concentric shells, but the question is not a nonsense. So you can do this question ultimately. I think it should be like R square, or R square should be the denominator. By dimensional equality it should have been D. Okay, that is a very cheap way of doing it, but still you'll get the answer, guys, if you do the dimensional analysis. And okay, but that is the way you have to think in the exam. Q is distributed, of course, at the center. It's not going to be 0, and we discussed it's not going to be Q plus Q by R, something like that. Q divided by R plus R. The leftover option for us is can we equate this to be so yeah, I think it have been D. Okay, but the apt way to solve the earlier question was the surface charge density is equal, so it should be like sigma into 4 pi r square plus of sigma into 4 pi small r square is equal to Q. So your Q is going to be so your sigma, you will have a value for sigma, and from that you need to put down the value of sigma in the final equation, and there would be an r in one denominator, r in other denominator. So it's like a 10-step question, but maybe by dimensional equality you can do it quicker. I still don't think Q divided by R will be the answer, because epsilon naught has to be obviously present in the question. A little bit of dimensional analysis what I did. So let's come to this question. This has already been discussed. So decreases or increases because it moves along the electric field, isn't it? All right, guys. All right, we'll discuss some part of the questions. Of course, we'll pick it up and I'll discuss it. Whichever part you like, you can let me know. All right, we'll get into such topics moving forward. We haven't started this topic as well. We need to do this. A metal sphere having radius r1 charged to potential v1 is enveloped by a thin wall conducting spherical shell, and this is of radius r2. Determine the potential r2 acquired, v2 acquired by the sphere after it has been connected for a short time to the shell by a conductor. So what you need to do, first of all, analyze. So potentially it has to be equipotential surfaces, right? R2 and R1 will become an equipotential surface. Both the spheres has to be equipotential. They have been connected. So potential is what you have to equate, and there you take some, what was the charge on the small sphere? That's going to be like k you can write it down as kq by r1 is equal to v1. That way you'll be able to find the value of q1, which is going to be like what, v1 into r1 by k is equal to q, and now this q is going to be distributed among both of the shells such that the potential are equal, and that is going to be k into q, some q dash by r1 plus of is equal to k. So it would be in the ratio of the charges, would be in the inverse ratio of the radiuses, the radii, and that is how you have to do it. We will take up this question, okay? We'll take up this question and we'll solve it, okay? Don't worry about this. Alright, guys, I think this was an amazing quiz and we had amazing people and really amazing Ambika, really amazing Gopal, really amazing Gopalakrishnan, really amazing Mahendran, really good Nagendra. But Nagendra, you should have been early so that you would have got the hints and you would have got the all the solutions as well. And that being said, guys, I think we'll discuss this question as one, okay? I don't think I will remember this question. It's not a big deal. All right, I'll remember this question. It's not a big deal. So next, I don't think there is anything. Okay, this is also a very tricky question. Q is distributed over 2. And as I told you, the answer should have been by dimensional consistency. It should have been Q into R plus R divided by 4 pi epsilon naught r square plus r square, but that is not the way to do it. This is not a killer question, so you can try it out on your own because charge q is distributed. Okay, we'll do 2 of these questions. Let me just memorize this question. A charge q is distributed over 2 concentric shells of radii r and r such that the surface densities of the arc are equal. Okay, surface charge densities are equal and they are placed on the same axis, and the potential at the common center is going to be. Okay, let me memorize this question. And this question is going to be v1 r1, and the other one was r and r, something like that, I think, and the common center is being asked. Okay, these two. And what was this is math, guys. This is complete math. You need to do a lot of math and you will get the answer ultimately. So this is basically differentiating. So we have a similar question in our this thing. This was simple. This should have been -1 by 2. There was only one option which had -1 by 2. I told you in the during our session itself. And okay, we'll take up those 2 questions, right, which I wasn't able to complete, but the method is going to be that only. Method is not going to change, so don't worry about the method. So we had another question. So we'll discuss this question. This is part of today's lecture, so don't worry. And yeah, this is also quite simple, I think. So it should have been q self and y q self. All right. All drop of mass m. All right, this has been discussed, and I think this it should be potential is equal to 0. All right, let's move on to the solution then. Okay, is there anything else? Let's verify the graph question. Graph question at the center, the net force charge is 0. That's the question. Yeah. The answer is not given. All right. All right. Rest is all clear, I guess. And let's the first one. I think it's a very CV square is called MS delta T. Get the answer. All right. Let's then. I believe we need to only discuss the last two problem statements where you had potential V1 on it, and later on what is being asked, determine the potential V2 after the shells are connected. And V2 is potential on shell 2, isn't it? Okay. And the other one was this, a distribution of charges or something like that. Okay, let's get into both of these questions. Okay, let me quickly quit this, thing, the lecture. Right. So there we go. All right, guys, we have two things to discuss. Let me close out this app, else it will be slow. Right there. So we had two things. One we wanted to discuss was, I believe, first of all, let me get blank sheet. Just white screen. What we need, a pen, and there we go. Switch off the this. So one question was something like this. There was a large sphere, and this large sphere, oh my goodness, okay. This large sphere was connected to a small sphere. Okay, and what happened, it initially had V1 and radii R1. This large sphere is again a conducting shell as well, but this guy has radii of how much? R2. Okay. Now the thing is, what did we do? We quickly connected this with like a short wire or something like for some time. That means what would happen? Ultimately, they both should have same potential. Okay, if this has acquired V dash, this will be also acquiring V dash. And I think they have asked us the potential and not the charges on them. I think the question was actually very simple. So initially, what is conserved? Charge is conserved, isn't it? So what did we have? So let's say V1, when only V1 was present, when only one charge, like only one sphere was charged, KQ by small r1 is equal to V1. And from here you will get Q is equal to V1 into R1 divided by K. Okay. Now this is one of the equations that we have. Now what do we know? We know something like this. What do we know? We know something like this, that Q, let's say Q dash or Q1 is the charge on this now after connecting the wire, and this is on Q2. Q1 plus Q2 is equal to Q, right? Which is going to be V1 R1 divided by K. And the next thing that we have is K Q1 divided by R1 is equal to K Q2 divided by R2. Okay. The potential should be equated, right? Once they are connected, the potentials will be equated. There is no other way for this potentials to go about it. So K Q2 by R2. Simply solve this, both the equations, and you will get the answer. Ultimately what they want is V dash. So we need to find out Q1 or Q2. Either one of them would be fine. So you need not worry about it. I would rather go with substituting Q1 because I feel it's easier to eliminate things. It's just a matter of, like kind of fusion, you can say. So I'm going to substitute Q2. Okay, I will be substituting Q2. Of course, I'm going to be trying to derive everything in terms of Q1, because that would be a little bit easier compared to doing, this is what I believe, but I don't know really what is the actual thing in this. So I should be substituting Q2. So if I'm going to substitute Q2, going to be R1 or R2 divided by R1 is equal to Q1, isn't it? Yeah. Just substitute this value. What do you get? You will get something like this. This being substituted. I'm quickly writing down the solution. I'm not going, step by step, etc. Because it's just I'm discussing the quiz. So we will have some of the concepts that have not been discussed in the class that we will do step by step. But now try to quickly understand what I'm trying to do over here. And I got something like this is equal to V of V1 R1 this thing. So I'm going to erase this part where what did we do over here? This is V dash, isn't it? This is V dash. Okay, we need to find out what is this V dash. Okay, that is what we are going to do. Now what we need to do, guys. Now what we need to do is first of all find out Q1, because I know KQ1 by R1 might be a simpler one, may not be necessarily. So it's going to be like Q1 is equal to V1 R1 whole square. Are we doing it correct? Yes, divided by R1 plus R. Okay. And ultimately we need to get it in terms of KQ1 by R1, right? So and we have K on the denominator. Okay, let's verify the solution as well once completed. So we have this, which is correct. KQ1 by R2 is equal to KQ1 by R1. Both are connected. 1 plus Q2 is equal to Q, which is nothing but V1 R1 divided by K. And once we equate this, we know Q1. What is the new potential, guys? The new potential is going to be V dash or V2. Actually, in the question it was given as V2. So it's simply like V dash is equal to K Q1 by R1. Hence you would be getting it as R1 square. 1 R1 would not be present anymore, and we would have something like V1 R1. K would get cancelled out, so we would have something like V R1 divided by R1 plus R2. Okay, I believe you understood what needs to be done. You need to basically equate the potential, and you will be able to find out the charges. You will take up similar questions in the upcoming sessions. Don't worry about it if you haven't understood it, but the concept is really simple. Let me explain to you again. So this question, potential V1 was given, R1 was given, which is kind of the known things. Rest of them is not known. So you need to first of all find out Q in terms of V1. Q in terms of V1 from this equation, from the normal potential equation, it is going to be KQ1 by R1 is equal to how much? Q1, so from this, Q is going to be how much? V1 into R1 divided by K. And charges are conserved. So this Q is nothing but equal to that of Q1 plus Q2. Okay, Q is equal to new charges Q1 plus Q2, which has been distributed. And how they are distributed? They are distributed such that the potential is equal. Right, both of them would have same potential, right? KQ2 by R2 is equal to KQ1 by R1. That way you would have Q2 is equal to R2 by R1. I substituted the value of Q1 over here, Q2 over here, sorry. So I got it something to be like R2 divided by R1 plus 1 is equal to V1 R1. And from this we got this equation or this expression for Q1, which has been easy to deal with, which has to be substituted over here. That is it. That is it, right? Simple. I believe this was simple, guys. All right. So yeah, this is all correct. Dimension it is fine. Everything is fine. All right. So let's move on to the next question. I think this was one. The next question was what? I think the next question was something like this. There was two spheres. One had radius small r, and the other one was like another concept. There was two shells. and the other shell had some radius capital R. Some Q charge is given to them. Some Q charge is given to them, and this Q charge is distributed such that the surface charge density is equal. Okay, so in the question it was given the Q charge is given to two spheres with radius R, small r and capital R, such that they have same surface charge density. And what was asked in the question? I don't exactly remember. I think the potential at the center was asked. So they asked you what is the potential at the center. So you are supposed to determine potential at the center, right? First of all, understand this thing. Q, if surface charge density is uniform for both of them, that means sigma into 4 pi r square, capital R square, plus sigma into capital not this time small 4 pi r square is equal to Q. Okay, from this you can determine the value of sigma, right? That is going to be something like Q divided by 4 pi r square plus of r square. Okay, now I've just taken that as common, guys. Okay, don't worry, it's just a common term. Now the thing is, we got this expression. Now our concept was to find out the potential at the center. How do you find the potential at the center? The potential at the center is going to be DC is going to be K into, we did a similar thing. Okay, let's keep it as Q1 or small q by r and capital Q by r, just for now. Small q, let's say, is the total charge and on the small shell. Capital Q, let's say, is the total charge on this larger shell. So what is going to be the potential at the center? K Q by r plus that of K into capital Q by capital R. What is small q, guys? Okay, this is what we are finding out. What is small q? Small q is nothing but 4 pi r square into sigma. Okay, 4 pi r square into sigma. And what was capital Q? Capital Q would be similarly 4 pi capital R square into sigma. Yeah, now it's a problem of math. That's it. Now you need to solve it. Alright, now what do you need to do? You need to substitute the value of sigma and you need to get the value, guys. That's it. So it's a lot of math now, a lot of arithmetic remaining in this case. So I'm going to take out the K as common, and Q I need to write it down as 4 pi R square into sigma. And you can see somewhat, you can see 4 pi is going to get cancelled out. So we will quickly cancel out the 4 pi. I'm going to carry forward this equation over here, since this might not be doable in one page. Now what we need to do, so I'm going to substitute the value of sigma. Sigma is also common. If you noticed it, 4 pi sigma is common. Let me erase this and write it down. Okay, we have only one blank sheet. We'll erase it and write it down. So 4 pi sigma is common. R square plus R square. R square plus R square. 4 pi sigma is common. Right, is that what we have? Yeah, I think somewhere we are going wrong. What are we doing wrong? We are doing wrong that this should not be R square, but this should be just R. Smaller, smaller, okay? Alright, I'm just correcting that part. So here it would have been KQ, what is Q? 4 pi R square sigma. 1 R would get cancelled out, and here it would be 4 pi R square sigma. 1 capital R would get cancelled out, but 4 pi sigma can be taken out as common. What is 4 pi sigma from over here? It's Q by R square plus R square. Simply substitute it. What do you get? You'll get something like Q, 4 pi would get cancelled. Sigma, when you're going to 4 pi sigma, what it is? Just carry this 4 pi over here and think about it. It's going to be Q divided by R square plus R square. Q divided by K into Q divided by R square plus R square into R plus of R. From the given options, we could have done it by the dimensional consistency method, but yeah, this is the way to completely do work around this question. Alright, I think we have discussed both the questions. Let's move on to the lecture then, the lecture of the day. We have a lot to discuss today. And students, that being said, I'm Murlidharan Gopalakrishnan. I completed my MS in Electrical Engineering from CU Boulder. I'm also an IIT, completed BTech from IIT Guwahati. I have 4+ years of experience preparing students for IIT JEE and other competitive exams, and I filed 25 patent applications in India and abroad. And guys, yes, this is the way to get on to the quiz. And we are on to the 18th lecture of electrostatics. Make sure you're completing rest of them. At least you get started with electrostatic potential. Even if you're a 2022 aspirant, this is the place to get started. And that being said, the most competitive gamified IIT JEE battle ever is going to be on. Compete live and win rewards and prizes. And guys, you know what, do not forget to apply Murli code while you enroll, and make sure you are attending this competitive gamified battle, because here you can win Amazon vouchers and whatnot, Apple products like MacBook Air, etc., iPhone, MacBook Air, etc. So yes, do participate on it. It's going to happen on 22nd of November. And guys, that being said, if you don't have a Telegram app yet, just download it from your Google Play Store and App Store. And once you do that, just click onto this link. This link is available on in the description box below. And what you get with this link, you get before time, on time, and all kind of updates on lectures being conducted on JEE English channel. Not only that, we also provide you before time updates on every lecture that we conduct on that we conduct on Unacademy Learning app. So our team, we have like an awesome team of lecturers who keep conducting lectures, educators, JEE educators who keep conducting lectures in English, and they are all conducted on Unacademy Learning app as well. And that being said, do not forget to cover units, dimensions, and measurements. This is the easiest topic that you can do for your JEE Mains and JEE Advanced. The kind of justice that you will do by attending 4 sessions is more than what you would be doing by attending 10-20 sessions of other lectures. And these are all like back-to-back session, an easy topic, and you definitely get a question in your JEE Mains and JEE Advanced. Combined, you get 2 to 3 questions in your JEE Mains and JEE Advanced. And guys, this is the easiest topic among all of them. And not only that, it's less time consuming. Not only easy it is, and not only less time consuming in terms of preparation. All you need is 4 sessions plus an extra session, and yeah, 1 extra session you need to do apart from this 4 session, where we'll be discussing a lot of model problems. And it's not only less time consuming during your preparation, but also in your exam. So do cover this session, guys, and it's all available for free of cost on Unacademy Learning app. And that being said, students, you know what, if you don't have an Unacademy Learning app yet, please do download it, because you could have attended today's quiz. And more importantly, guys, this is the most downloaded learning app, and all you need to do is just type in Unacademy on your Google Play Store and App Store, and the first search result is going to be Unacademy Learning app. Just click onto this and then click on this install button. Okay, and then click onto this install button. Do not hesitate to do that. You will get live notifications on every class happening on Unacademy Learning app. And yeah, Deva, Varun, hi. Yes, just click onto that install button. And more importantly, guys, you can attend free quizzes. You can start attending Unacademy Combat, and follow me to get live notifications on such classes. And right now, Capacitus is going on special classes. Do cover it. You have this Diwali vacation. Make sure you are covering lectures, guys. Okay, make use of your vacation. If you are especially a 2021 aspirant, the vacation might not be for you. 2022 aspirants, it might be for you, but still I would say, try to take advantage of this vacation. 2022 aspirants, you can't avoid it, but 2021 aspirants, take advantage of the vacation. Try to cover your backlogs. Make sure you are on track. And that being said, students, if you're looking for a champions tool for your JEE preparation, the best platform for your JEE preparation, it is going to be Unacademy subscription. And guys, all you need to do is click on the left hand top corner extension bar, choose plus, choose IIT JEE as your goal, and click on this get subscription button. And what do you get by clicking on this get subscription button? You will get daily interactive classes with the best educators across the nation. And not only that, guys, not just about like daily interactive classes, but you can get your doubts cleared from them on time on each and every topic that you would like to, the kind of topic that is being conducted generally. You get dedicated doubt clearing session, and also doubt clearing session on each and every topic around that particular topic, like optics, etc. And not only that, you will also attend dedicated quizzes, mega quizzes, national level test series, doubt clearing sessions, and more importantly, you will have leaderboards and dashboards. So this is kind of the best thing that you can have for your JEE Mains and JEE Advanced preparation. Guys, it is one subscription, unlimited access throughout the period, so you can enroll to as many programs as you want. And that being said, guys, this all comes at a price of 2,100 only, less than 70 rupees a day is what you have to pay for it. And guys, whom does this package for whom is this package meant for? It's typically meant for 9th class, 10th class, and 11th class students if you're going for a 24-month subscription. And yes, students, you can start early. And guys, you will get it at a price of only 70 rupees a day with the best educators across the nation. So think about it, and you can attend the classes from anywhere. And it's going to be a structured program. And what do I mean by structured program? We will take you in a very systematic manner, like what we have said, daily interactive classes combined with doubt clearing session. Every fourth session is going to be a doubt clearing session. And yes, apply Murli Live coupon to get the best discount on your subscription purchase. So do not miss out the best discount on your subscription purchase, guys. So yes, this is how you'll get the best discount. So make sure you are getting the best discount. And that being said, you can split your payments into multiple parts using our pay in parts in-house feature, where you don't have to go through the hassle of paying all the fee at once. And we also have access to no cost EMI, which also typically takes away the burden of paying all the fee at once. So these are two typical payment options that you want to check out before purchasing, or if you're planning to purchase an academy subscription, because these take away the burden of paying all the fee at once. You also have access to traditional payment options like debit card, credit card, and UPIs. And that being said, students, we also have a 12-month package meant for 12-month package meant for long-term and dropout students. This is typically for long-term droppers and like 12th class students aspiring to prepare for only 1 year. And this all comes at a price of less than 2,900, only 2,888. And how do you get to this price point? You apply Murli Live coupon. So do not forget to apply Murli Live coupon. And that being said, students, it's not just about 12-month packages, but we have dedicated programs like Droppers Batch, and we have 7,000 plus recorded materials, and we have 1,000 plus live programs going on right now. So this is the time to get started. You will be getting to attend dedicated classes with dedicated people across this industry with expertise in them, and that also hosting dedicated programs for your JEE Mains and JEE Advanced preparation. So that being said, do not forget to apply Murli Live coupon. Let's get into this session, and before that, let me tell you guys, enroll to Optics Basics to Advanced coursework. If you haven't started yet, do it as soon as possible, because this is going to be a comprehensive course for your optics. Why comprehensive course? Because you will be getting to attend both ray optics and wave optics in a single go. And guys, this is going to be the complete coursework. In terms of the kind of concepts that we are going to cover. We are going to cover anywhere around 65 plus concepts, and then 65 plus sessions, and 100 plus concepts and 65 sessions with 300 plus model problems is what we are going to do in this course. And you don't need any prerequisite to attend the session. You can get started even today, and you can start attending the recorded lectures, and you can start attending the live lectures. It happens so from next week it's going to happen from 5:30 but tomorrow it will be from 6 to 7, but from next week, Tuesday to Friday, you will be able to enroll to this class and attend this class from 5:30 p.m. to 7 p.m. guys. 5:30 to 7 p.m. you can attend this class. That's all you need to do. 1.5 hours a day. You will be thorough with optics. And yes, it's a comprehensive course and it has just been launched. Do not forget to enroll to this course if you are already on subscription platform. And if you're planning to purchase subscription, do it. This is the time, and enroll to this program. And that being said, practice, practice, and practice only makes human perfect. And typically this is true in the case of electrostatics. But let me tell you, electric potential is a lot easier topic than this. So yes, let's get into this topic then. Alright guys, an infinite thread. So this questions, like first few questions, will be dealing with the questions that have been asked in the quiz, because some of them cover the model problems or the concepts that we haven't previously done. Okay, even though I've discussed one on similar one, but yeah, let's go out and discuss. Let's go ahead and discuss this thing. And don't worry if you didn't understand it. We will have lectures on them. I'll bring up different kind of model problems around them. So an infinite thread of charge density lambda lies along z-axis. So this is the z-axis and this is this infinitely long thread. Now the potential difference between 2 points A 4, 3, 4 and 3, 4, 0 is going to be what? So think about it. One is on 3, 4 somewhere on xy plane, and the other one is somewhere else. So, okay, we have been given like 4 options, but let me quickly take you through this question, how to solve this question. Okay, in this case, this question, what you have one on xy plane somewhere lying at basically 3, 4, and the other one is shifted by some 4 units along z-axis, and that's going to be 4, 3, 4. Okay. This is not shifted just by z-axis, but both along x and y axis. So, but anyway, at this point would be lying somewhere over here on the top, here. Somewhere like this, not exactly like this. Let me redraw the points quickly. So this axis is not giving us the correct feel of what we should be doing. So let's assume this is 3 and this is going to be the 4, and we are going to draw a point like this. So this is 3, 4, 0. So 4, 3, 0 would be somewhere over here, but shifted along z-axis. This is what it is going to look like, 4, 3, 4. But the thing that you need to notice is these would all lie on an equipotential surface. Okay, if you draw a cylinder around it, and you can draw a cylinder around this, and you'll notice these are all on equipotential surface. This is a little tilted diagram, so the cylinder also looks a little tilted, but as such, there is going to be a Gaussian cylinder, cylindrical surface. If you notice, it's going to span all along, right? Of course, one radii would not be covering it, but 2 radii will be covering it. Just showing you just with a single kind of line, but it's going to be a Gaussian cylindrical surface. This Gaussian cylindrical surface, what does it have? It has same potential. Since it's infinitely long, if it was not infinitely long, this would not be true. You would have to calculate it like how we used to do it for initially for electric field. Then at that point you would have to calculate the electric. Okay, so this is an equipotential surface since it's an infinitely long thing. And what is the radius from z-axis is what you need to know. This is going to be like 5, and for this as well at this point it's going to be also 5, but not from origin. Just let me correct this quickly. It's not going to be from origin, but from point z is equal to 4. From point z is equal to 4, we are going to draw another radii, and this radii is going to be also 5. Hence, both lie on an equipotential surface, and the potential difference between them is going to be 0. Okay, this was one of the questions in the quiz. Alright, Let's move on to the next one. I think we did a very similar one yesterday. We discussed this point. So how do we do this? V is equal to k into 2x square minus y square plus z square. Don't worry if you haven't attended yesterday's session, you can still understand this because I am going to start this concept right. And we perfectly have the question and we would understand it really well. So in a certain region, the potential is given by this, kind of like equation. It's a function. It's a space varying electric potential. Now from this I need to find out electric field. So how do we do this? If you remember, we had this equation. Okay, let's move on to this question then. So any guesses? First of all, you must start trying it on your own. Why don't you get started on this? Even though we know how to do this. I might have told you verbally how to do this. We'll now solve it. Alright, should we get started then? So first of all, okay, this is going to be like the concept that you need to know, guys. You need to note down this thing. Plus dou v by dou y j cap plus dou v by dou z k cap. Okay, that is how you would be doing this. There would be negative sign. There would be negative sign. Do not miss out this negative sign. This is what you need to do. What are we doing over here? Partial differentiation of this potential, electric potential function, whatever function it is with respect to R, you would be partially differentiating it. So basically, how did we get this equation? We knew something known as V is equal to minus E dot dr. If in this case, I am going to, differentiate this thing with respect to dr, E dot dr, this would become just E minus E. I am taking this minus E on the other side. You will get something like dV by dr. dV by dr can be written in this way. It is the same thing. Now carry forward, actually, like more exactly said, this is right. That is it. Now how do we work around this equation, guys? Simply throw in the values, substitute the equation and get started on this. That's all you need to do, right? That's all you need to do. Keep the minus sign outside. Now differentiate it with respect to x, partial differentiation of this function with respect to x. Okay, more aptly said, partial differentiation with respect to x. So y term would not come, z term would not come, only this term would come. We'll take up another such kind of equation as well. So this is going to look like 4xi cap. So second time when I differentiated with respect to y, partial differentiation with respect to y, and it's the same thing, differentiate with respect to y. This is going to be 0, this is going to be 0, only this term is going to remain. And what you are going to get? Minus 2y j cap. And the third time when I differentiated with respect to z, what are you going to get, guys? It's going to be as simple as 2z k cap. Because here there is no z, here there is no z. When you do the partial differentiation, only this would be left. 2z k cap is all you would get. That is it. That is it. Now what you need to do? You need to substitute the value of x, y, z. But before that, let me tell you, this is how your electric field in this space would look like. Okay, if vectorial equation is given to you, this is how your vectorial equation would look like. Remember this negative sign. If I take this negative sign inside, minus 4x plus 2y minus 2z k cap. So be very cautious about what you're doing. And the next thing you want to do is electric field is equal to minus 4xi cap. And I'm really sorry. This is at a point R in space. Let me define this. What I wanted to say was we wanted to find it out at 1, 1, 1. Hi Cheswara, yeah, of course, yeah, hi, welcome and good evening. Get started, Cheswara. This is like a new kind of model problem that we are discussing. So now at 1 comma 1 comma 1, so see, one way is like what has been asked in the quiz. They can ask you for the magnitude. This is like the magnitude part, but they can also ask you about the vectorial expression. Very good, Suraj, very good. But what about the vectorial equation? And Suraj, I hope you have seen the last video. I've cleared your doubt. So substitute 1 and substitute 1 j cap and substitute 1. That's it. You need to substitute the value of x, y, z. Alright. So this would be minus 4 I cap. This should be all inside the bracket. Minus 4 I cap plus 2 j cap minus 2 k cap. So this is exact, value, or you can say the exact electric field expression at 1 comma 1 comma 1. Okay, if aptly written, this is not how it should be written. This is how the electric field would be at 1 comma 1 comma 1. I think I took up your doubt in yesterday or day before yesterday's session at the end. Okay, at the end I took your doubt. I don't, let me think about it. I think it was day before yesterday, Suraj. Day before yesterday, I got your question. I think on Monday, yeah, on Monday I did it. Okay, on Tuesday, sorry. So it was day before yesterday. After the quiz, at the end, it was the discussion about your query. Okay, you can check it out later on. So that is it. And now this is the exact expression at 1 comma 1 comma 1 for your electric field. Now the thing is, you need to find the magnitude of the electric field. Basically, you need to apply a mod. And what would that be? This would be 4 square plus 2 square plus that of 2 square. Right? What was electric field? Electric field value we found out to be minus 4. And there was a k as well. I think we are forgetting the k part in this case. There was a k, there must be a k, there must be a k. Okay, this entire thing multiplied by k. Okay, let me quickly correct this point. So thing should be k. K. I have two k's. This is a different k. This is a constant k. This is not a Coulomb's constant k. So we had something like minus 4i plus 2j and minus 2k into k. Right, and here also that capital K would be there. You can work around this. This is going to be under root 24 k, which is basically like what Suraj said. This is going to be 2 root 6 k. This is magnitude of electric field, and this is the exact value of electric field. Do not forget to multiply it with k. I thought the expression should have k in it. That's a k as well. You're welcome, Cheshwara. Hi, Venkatesh. Hi. Yeah, you're welcome, Suraj. Students, there's a little bit lag in the chat for some reason. You're welcome, Cheshwara. But the thing is, Cheshwara, try to be regular and try to cover everything. Don't miss out even a single lecture. If you're starting with electrostatics, okay, electric potential, you cover those 5 lectures, but ultimately you need to go into electric field. Soon we'll be getting started with electric dipole. At that moment, you don't want to stay behind. So make sure you are taking advantage of this holidays, especially if you're a 2021 aspirant, guys. Alright, let's take up another question. This is going to be a little bit advanced question, and I think this was asked today in the quiz as well. I took up this question because this is a real complex kind of question, but I don't think this complex and a calculation will be asked in an exam. If it was asked before, you need to make some real guesses, nearby guesses. We will also try to understand how to do that. But for now, let's understand the method. Now, what is given to you? Now, in this electric field challenge problem, I don't have like multiple answers for you. Let's say I have to find out first of all electric field value at some point 3, 2, 1, and also the expression for the electric field. How do we do this? Again, let's get started. Electric field is equal to minus dou v by dou x I cap plus of dou v by dou y j cap plus dou v by dou z a cap. Same thing, same expression is what I've written. But now the thing is, you know what, I'm going to write the electric field E over here because our dou is going to be little bit lengthier. Okay. First of all, in this case, let me do a thing. I will move little systematically, deriving dou v by dou x. Dou v by dou x is what? This whole expression partially differentiated with respect to x. Notice this first thing. Let me erase all of this part. Okay. So notice this first term. There is an x in it, right? There is a x in it. Now, when you differentiate it, what would you get? 6xy. Okay, 6xy. 2x, right? 3x square, 2x, 6xy. And then this term does not have any x in it. So this is going to be 0. And this is going to be 7z square. Only one x is present. 7z square. So this is how you work around it. You must have done this in your mathematics class. Right? This is dou v by dou x. Next. We have next thing known as dou v by dou y. When we start doing dou v by dou y, you will realize it's quite easy because you're already accustomed to this process. So don't worry about it. Let me quickly erase the rest of them and let's move on. So we have this first term which has 1y in it. So this would appear as 3x square. 1y is gone. Now in the second term you will see y square, so it's going to be 2y when differentiated with respect to y. So we are going to get 10y and there would also be a z. And the last term of course is going to give you 0 when you are going to do dou v by dou y. Alright. Similarly we need to do it for z. To do it for z. Dou v by dou z is going to be how much? This is going to be first term 0, second term 5y square, okay, and third term it's z square, so it's going to be 2z when partially differentiated, so it's going to be, this term is going to give you 14zx. Okay. But this is just dou v by dou y, dou v by dou x, etc. So now what you need to do? You need to do something known as write down the equation for electric field first of all. I'm just going to carry forward it. Don't worry. Do it all along with me. It's going to be very easy. Okay. That's all you need to do. Let me carry this equation. Okay, I'm going to write it down directly. You can note it down later on. Now focus on the method. If I'm going to ask you electric field at any point, I'm basically going to make use of these three things that we have derived and we'll write down the electric field. So electric field at any point, or in this case for this given potential equation, it's going to be what? Minus of, so we would have something in the first bracket. Let me do a thing. I'll make use of a square bracket this time. So we have better clarity. Generally just a habit, a good habit to have. So inside the first bracket, what would you have? 6xy plus 7z square I cap. And the second one, it's going to be what? It's going to be y with differentiation with respect to y, 3x square plus 10yz j cap plus of, what did you get? You would get 5y square. I'm just carrying that equation, don't worry. What have I written? You know, dou v by dou x, dou v by dou x, I cap. This dou v by dou y, j cap. I'm writing down dou v by dou z, k cap. That's what I'm doing, just carrying forward that equation. Okay, just substituting things that we have derived earlier. That's it. This is going to be 14 z x k cap. Okay, and let me do a small thing. Now, the thing is, if I've asked you what is the electric field value, Suraj, have you written something? I didn't notice your chat. You can type it out again. So if I asked you what is the electric field value, how would you do this? You would simply substitute the value as it is going to be. Okay, now in this case, electric field at point, very good, Suraj. It's a little bit complicated math in terms of magnitude, but try to understand each and everything that we are discussing. I think, Cheshwara, there will be scholarship test on Unacademy, so we'll keep you updated. Don't worry, we will be, bringing up such information as soon as we get it, so don't worry about it. I'll keep you updated on it. So electric field at point 3, 2, 1, what have I done? I'm substituting the value of x and y. X is 3, y is 2, and then what you have, 7z square, 7 into 1 whole square, whole thing of I cap. And then what do you have? Then you have 3 into 3 square. Basically, I'm substituting the value of x. And then what are we doing? 10yz. Y is how much? 2. Z is how much? 1. J cap. Carefully, guys. Carefully. That's the reason I'm going very slowly, else the answer could have been directly even be written. So notice things very carefully. 5 y square, y is 2, plus of 14 zx, z is 1, you know that. Z is again 1, and what is x value? 3. So 14 into 1 into 3, and this all in one bracket. Little bit lengthy expression, but in exam you don't want to do it this way. You want to directly deduce each and every term directly if possible. At least try to combine this term so that it will be 1 square is going to be 1. You don't even have to write this thing. It's basically 7. So quickly doing it, it's 6 into 3, 18 into 2, like 36. 36 plus 7 is going to be 43 or 44. 43, 36, right? Yeah. Obviously, even odd added, it cannot be this thing. Cannot be even again. So yeah, 3, 18, 18, 2, 36, 36, 43 I cap. And then here we would have something like again, let me change a few things over here. Let me give some space because I need to understand. This is at 3, 2. Okay. Exactly writing it down. It's not a R anymore. The R is 3, 2, 1, 3 I cap plus 2 J cap plus K cap. So now electric field at 3, 2, 1 is going to be what? Going to be minus 43. We just derived that. I calculated it. 43 I cap plus of 3 cube. Basically 3 cube, 27. 27 plus 20. It's quite easy. 47. You'll have it. 47 J cap. And here it is going to be 2 square 20. 20 plus of 42. 20 plus of 42. 14 3 is 42, right? And that is going to be 62 K cap. This is, first of all, let me mark two things. One, what is this, guys? This expression over here is electric field at any point in space. This thing that I'm running over right now is electric field at any point in space. You need to basically substitute the values and get it. Okay. Alright. And the next thing is going to be, so see this thing, unlike the earlier one, it's not just dependent upon x, but it can also be dependent upon the position y. Earlier one, x component was only dependent upon x, y component was only dependent upon y, z component was only dependent upon z. But now what do we have? We have something around it where electric field at some point is dependent upon x, y, z. Notice all three terms. It's a unique kind of problem. Yeah, it's quite possible you get this, but not such a complicated expression. Not such a complicated, generally not such a complicated expression. You get such a complicated expression, try to approximate things and try to get some value. There is no other go than this. Okay. Alright, and at 3, 2, 1, I basically substituted this value as you saw in this equation. So this is exactly the electric field. This is exactly the electric field at 3, 2, 1. Okay. What you need to do basically, you need to, if I'm going to ask you the magnitude, it's going to be like under root of 43 whole square plus 47 whole square plus of 62 whole square. Okay, remove the negative sign is no more valid. Now this you would get to be something like, you know, according to your question etc, something like 88.9. But that's a pre-calculation. Let's say you have this in exam. So how would you do this? And let me tell you, if I had been you, what would I do is basically take 245 whole squares and 160 square and add it up and see where does the value lie between. Try to guess the answer. Okay. The reason is this is what. Let me just quickly verify this. This is what, this is 45 minus 2 whole square, this is 45 plus 2 whole square. So you would have basically, if I had been solving this question in exam, trying to guess the answer, I don't have a calculator. So the way I would be approaching this is, okay, you get this answer to be something like 88.9 etc, or something like that. I exactly don't even remember, some Newton per coulomb. Okay, this would have been in volts, then only you would get it in Newton per. Okay, so if it had been an exam, let me just quickly verify the calculations. 18 2 36 plus 1 43 and 3 square, that's going to be 27 plus 20, that's going to be 47. Okay, let's now get into the interesting part of it. So what did I say? Instead of doing the entire thing, what would I have done? 40 one was 45 minus 2 whole square, and the other one would be 45 plus 2 whole square. 47 you had, and the other one was 43. Why are we doing this? You'll understand it eventually. The other one I'd keep it as 60 plus 2 whole square, because you know what, I'm not very efficient in calculating all the squares, but this is quite easy for me. Okay, even 45 I will try to make it as, you know, 50 minus 5 at the end of it. Little easier. If you reduce it this way, the calculations over the time will become really quick. Okay, so this would ultimately, this 2 and minus 2 would get cancelled. You will understand something like you will have something like 245 whole square plus of 2 whole square, and then here you would observe another, you know, like 60 square plus 2 square plus, you know, 2 into 60 into 2, that is going to be like 240 etc. For now you can even ignore this value, you are only worried about the squares, and you can just keep calculating it. You ultimately arrive to a point where you see it's near about under root 85. You match the value with under root 85, not exactly under root 85, but under root 87 and odd. Okay, and from there you can pull in the values and say it's approximately anywhere between 85 and 90. Try it out on your own, and you'll understand how to work around these terms. That is the key. Yeah, I will be basically ignoring these 3 terms. or just during exam calculation where I do not have access to calculators, etc. Maybe I'll do the 45 square because it is something that we need to do. Multiply it with 2. It's going to be easy, don't worry. All right. Yes, Cheshwara. Tomorrow there will be live class, guys. Tomorrow the class will be happening on this regular time from 7:30 to 9:30. All right, let's and tomorrow we are going to discuss a very important part of this electrostatic potential, and do not forget to attend. So that being said, let's take up one more question on this quiz. But this is not exactly the quiz question, but these kind of questions are actually very popular. Okay, tomorrow we'll take up equipotential question, another one, how to solve it, because this is around charge density. This will take a little bit of time. We'll take it up tomorrow. But for now, let's do this thing. See, a very standard rule. Okay, this is actually a very popular question. If you notice, if you take up any book, you will come across this kind of question. So what happens in these kind of questions is they'll combine multiple drops, they will coalesce and they'll form a bigger drop. Now they will either ask you, what is this potential energy of this drop, or what is this, potential energy of bigger drop, and ratio of that, potential energy of bigger drop to that of small. Try out this question once on your own and I'll get started. So 64 charge drops coalesce to form a bigger drop, and now the potential of the bigger drop will be how many times that of smaller. Alright, let's get into this question then. Alright guys, so what is happening is there are 64 small drops. They must be having some charge Q on them. Okay, now this Q has become a little bit bigger than the drop. Let's change it. So 64 small drops, charge Q on them. The radius is, let's keep it to be like some r, small r. Okay, and they coalesce to become a large drop, and this large drop maybe like has a radius capital R or R dash, and how much charge do you think this is going to have? See, charge is going to be conserved. So 64Q would be the charge present on this as well, but all the 64Q would be present on this one sphere. Okay, all the 64 would be present on just this one sphere, 64Q. But this R dash has changed. I hope you understood this thing. From conservation of charges, let me write it down. From conservation of charges, we can say the large drop should have (64Q) all the charges on them. But this is not true for volume. Whenever you are given such question, first thing that, after having a look at the option, first thing that should run into your mind is what is going to be the radius R dash. Okay, this was not the same problem that was asked in the question. It was a little bit different. This is typically a little bit same kind of problem. So in this kind of question, first of all, try to calculate the value of R dash. How would you do this? Remember, this volume, what do I mean by this volume, is 64 times this volume is same as, is equal to this large sphere's volume. Large sphere's volume. What is large sphere's volume? 4 by 3 pi r cube. What is that 64 times small sphere's volume? It's going to be 4 by 3, of course, small pi r cube, I mean like pi r small cube, sorry, 4 by 3 pi small r cube into 64. Don't do the entire math, just cancel out the things that comes to your mind, like whatever you can see. From here you will find out something really easy to work around. That is r would be 64 is what? 64 is what is 64, guys? 64 is going to be 4 cube, 16 into 4. R should be 4r. Simple. Why did we calculate this? Let's move on to the next thing. Okay, two things we derived. R dash, let's keep it as R dash only. R dash is going to be 4r, and the other one 64 cube present on it. Alright, now we need to, of course, draw some things. Be like that small charge that we had earlier, which had q on it and radius r on it. So what is the potential of this? Potential of this is going to be kq by r. Right? Now what about that large big drop that coalesced, and this guy had a radius of not, this time I'm not going to write it down as capital R, but r dash rather as 4r. And how much charge? 64q. Simple. What is this charge of v dash, like this big drop? K into 64q, that is capital Q by r. If you're thinking about it, it's 64q by 4r. How much is this? 16 times k small q by r, which is nothing but, which says that v dash is equal to 16 times v kq by r. kq by r. Good, Suraj. Okay. So good. You reminded me of this. Really good. 1:4 is good, but read the question carefully. I'll come to that point as well. What Suraj is talking about. That's also one of the kind of questions that is asked. What was the net potential to that of like initial potential of the big drop? But generally it is asked around energy. It's not asked for potential alone. So it can be potential at some point r, it is kept that way. But the potential of bigger drop to that of smaller drop would be 16 times in this case. Okay. But what Suraj is saying was also true. What is sometimes asked in the question is, you'd have this small charge q, and they would say at some point, let's say distance a from it, these charges are present, like the system of 64 charges are present such that like they are at equidistant from a point A, and the potential, what is the potential at this point A? Okay, that would be like V total or V net, we can say in this case would be K into Q divided by A into 64, because in the entire space, like there would be like 64 such charges, so it would be 64, and that other one would be like this combined to form a large coalesced drop. So this is the other kind of problem that would be asked around this, and it is at a distance r away from the center. Okay, from the center it's going to be like distance a, distance a away from the center. You need to find out that potential. That potential in this case, let's again keep it as something like v n dash. That is going to be like how much? If you remember, we got it to be like 16 k q by a. Just changing the value of a. This is just asking about the surface potential. We are not talking strictly about all the potential. So in this case, then they are talking about, so read the question carefully if you have any issues, but these are like very good, you got it to my notice. These are typically like the two kind of model problems that would be asked. So at a point A, you notice at a point A, 64 drops at a point equidistant, okay, at a equidistant point A or equidistant point A for 64 drops. The potential of 64 drops Okay, to that of that one big drop is how much? 4:1. 64:16, which is going to be 4:1. This is another kind of thing that would be very popular. Okay, of course they're not going to ask you the total potential energy. It can be done if, let's say, they're talking about energy, all this like point charges. It's going to be 64 C2. 64 factorial is little tough to find out. So 64 C2, and you need to find out, 2 to all the system of charges. So I don't think that would be a kind of question that would be asked. Typically questions will be around this, or else they can give it in terms of factorial. At that time you should know. All right guys, so that being said, we'll take up more interesting questions tomorrow, so stay tuned. We have more and more interesting questions coming on, and tomorrow we are going to do a very important thing, that is going to be a non-conducting sphere. We already saw one thing at the center, how to calculate it. Now the other thing is how to calculate it on surface and how to calculate it at a point inside the sphere. So these are like two interesting perspectives that we need to learn, and we'll be working around. So stay tuned, don't miss out the classes, and stay regular. See you in the next class. Take care, stay safe, and I have a very important thing for you. That is like the most competitive gamified IIT JEE battle ever. But that being said, you need to enroll now, guys. Enroll now. With Murlidharan code, you will be able to attend this amazing Unacademy combat. It's going to be the most competitive and gamified battle ever, and you can win lots and lots of prizes from Apple products and hundreds of Amazon vouchers. And these are all some prizes that you can win, and more importantly, it's going to be a national level competition for IIT JEE preparation. This is one of the ideal things that you can do on 22nd of November. So do attend it. That is next to next Sunday. Don't miss it out, guys. And it's going to be one of the largest battle. And that being said, students, if you're on optics, if you're looking for an optics coursework, or if you're on Plus, or if you have already purchased subscription, do not forget to enroll to this optics basics to advanced coursework, in which we will be I didn't get your question. Is it available outside India? So Suraj, you are not from India. I mean, like, you don't stay in India. I think it is available, right? You need to download app, guys. So it's available everywhere, guys. I guess Unacademy Combat is available, but you need to download Unacademy Learning app. So you might have to download Unacademy Learning. Okay. And that being said, guys, if you're already on subscription platform, and if you already have Plus, or if you're planning to purchase one, enroll soon to Optics B2A Basics to Advanced coursework, where we'll be going through, every single concept of optics in 65 plus sessions, 100 plus concepts, and 300 plus model problems, and comprehensive coursework from ray optics until way optics, the only coursework that you would find on Unacademy, that too exclusively taught in English. So enroll now. It has just been launched. You can attend the recorded lectures as well. That being said, our team, JEE English team, is also on Unacademy Plus, where we have started courses on differential calculus, electromagnetism, optics B2A, and chemical kinematics for 2021 aspirants. We have also started courses for 2022 aspirants on mechanics, redox and equivalent concept, and graph sets and relations. So guys, everything that you want can be enrolled right now. Yeah, you're absolutely in. I guess you're absolutely in, Cheshwara. I think so. Once you need to check out, but I think my course is open, and I think rest of the courses are also open for some time until now, because it has not yet been 14-15 sessions, and you can still enroll, I believe. So you can check it out. Okay, you can check it out. You can enroll once, and then you can start attending the lectures. Alright, and that being said, students, do not forget to like the video, do not forget to share this video, do not forget to be regular to the session, and do not forget to click on that bell button and subscribe button, and work hard and smart to achieve your success. Avoid gossip, acquire knowledge, and share it with your friends, so that they also get the kind of knowledge that you have got. And that being said, students, if you haven't downloaded Telegram app yet, just download it from Google Play Store and App Store and post that, click on to this link which is available in the description box below. And guys, you can also type in JEE English to find us. And what would you get on this Telegram channel? You would get before time updates on every class happening on JEE English. Not only that, you will also get updates on every lecture that our JEE English team that you just saw now is conducting on Unacademy Learning app. So yes, this is something that you may want to have or that you must have for your JEE preparation. Amazing, Cheshara. See you tomorrow. And guys, be regular to the class. That is also very important. And do not forget to attend units, dimensions and measurements. A to Z of units, dimensions and measurements. And I typically conduct on Unacademy Learning app, A to Z sessions, revision, concept sessions, etc. on Unacademy Learning app. So on this A to Z units, dimensions and measurement sessions, you will get complete sessions on units, dimensions and measurements in just 4 back-to-back session. Hi Sigma, hi. Yeah, and all of this in 4 back-to-back session, and all you need to do is another 5th model problem session. I would typically recommend doing this 5th session as well. With this, your preparation for units, dimensions and measurements is complete. And why is units, dimension and measurement very important? It's a very easy topic. It's less time taking topic, and you can typically get 2 to 3 questions combined in your JEE Mains and JEE Advanced, and you will typically notice question every single year, guys. And it also takes very less time during your JEE exam. So typically a must to complete topic for 2021 and 2022 aspirants as well. But 2021 aspirants, especially droppers, don't miss it out, and 12th class students don't miss it out. Don't ignore, neglect this topic. It's an easy one, and you definitely get questions. Yes, Sigma, you're a little late, guy. Sigma, guys, the class happens on YouTube from Tuesday to Friday, 7:30 p.m. So try to be on time. 7:30 p.m. is when you have to be present to attend the classes. Yes, you're a little late. So on YouTube, try to be regular at 7:30 p.m. Okay, every day from 7:30 p.m. we will have the classes. It will span up until sometimes 9, sometimes until 9:30. Just between this time we'll be having the classes. And that being said, students, if you don't have Unacademy Learning app yet, download it from Google Play Store and App Store. All you have to do is type in Unacademy in your Google Play Store App Store, and the first search result is going to be Unacademy Learning app. Just click on to this and click on this install button. And guys, that's all you have to do, and you will have the best app where you can get live notifications. If you follow me on Unacademy Learning app, you will get live notifications. So do follow me, guys. And that being said, students, if you're looking for Champions Tool, a complete package for your JEE Mains and JEE Advanced preparation, absolutely, Cheshwara, will we keep doing this this videos. Absolutely, Cheshwara. We'll be doing more and more videos on this, guys. Don't worry. And that being said, if you're looking for a Champions Tool, the best in class platform for your JEE Mains and JEE Advanced preparation, it is going to be Unacademy subscription. Why it is going to be an Unacademy subscription? Because we have the best educators across the nation, and you can attend daily interactive classes with them every day. And not only that, you can get your doubts cleared. And more importantly, you will undergo an extensive and intensive structured program where you will be moving systematically and maintaining completeness throughout the topic. For an example, optics, you will be maintaining completeness throughout the topic, and you will be covering each part of optics in a very systematic and structured way, where you will be also getting doubt clearing sessions on each topic, dedicated doubt clearing sessions, and mega quizzes and quizzes, and also national level test series. We also have legends like DC Pandey sir on this platform. And guys, all you need to do is click on the left hand top corner extension bar, choose plus, choose IIT JEE as the goal, and click this get subscription button. And with this, post clicking this get subscription button, you'll realize this, it is one subscription, unlimited access throughout the period. Absolutely, Cheshwar, absolutely. I'll do more videos. So yeah, if you're planning to subscribe, get the subscription. And yes, Sigma, you're a little late. And guys, yes, it's one subscription, unlimited access, all at the price of 2100 per month, less than 70 rupees a day. Less than 70 rupees a day is what you have to pay for a 24-month subscription, and this is typically meant for 9th, 10th and 11th class students. And that being said, apply Murli live coupon. Do not forget to do that to get best and the maximum discount on your subscription purchase. You will get the best discount on your subscription purchase by applying Murli live coupon, and it is going to only cost you 70 rupees a day for all the kind of value that you get. National level test series, and we also have leaderboards and dashboards on every lecture. And that being said, you can also split your payment into multiple parts using our pay in parts feature, where you don't have to go through the burden of paying all the fee at once. We also have access to no cost EMI, using which you can split again your payment into multiple parts in EMIs, easy monthly installments, without bearing any interest on them. So yes, we have access to this two convenient payment options, which takes away the burden of paying all the fee at once. You can make use of debit card and credit card options as well if you would like to, and we also have UPI. And that being said, yeah, the code is Murli Live, guys. And that being said, if you're a long-term underdropper, a 12-month package is for you. Why? Or even if you're a 12th class. Why? The reason is, we have dedicated droppers batch. We have 7,000 plus materials for your JEE preparation and 1,000 plus live programs right now going on, and everything at a price of less than 2,900 after you apply Murli live coupon. So do not forget to apply Murli live code to enroll to Unacademy. Don't forget to apply Murli live code while you purchase subscription, because while subscription you will get the best discount, and during your combat you will be able to enroll in this thing. And guys, that being said, see you tomorrow with more concepts. Do not miss tomorrow's class, because it can be one of the topics that could be asked in your JEE Advanced or even your JEE Mains, because you know what, we are going to deal with non-conducting solid sphere, where you need to find out potential at the middle. We also take a few more concepts around this electric potential concept, where you have to differentiate and find it. But this time we are going to deal with charge density, and then we will take you to this finding electric potential somewhere inside the sphere, where you actually, you know what, you don't know, you can't determine it just like that, because it's varying with distance. So non-uniform charge distribution inside a solid sphere is what we are going to discuss tomorrow. We have already discussed one part to cover yesterday's video, and yeah, once to cover yesterday's video, day before yesterday's video. Try to maintain the completeness. Even after quiz, we keep conducting lectures, and do not miss out the quizzes. Good night, Cheshwara. Good night, students. Take care. Stay safe. Bye bye. See you in the next